Video Graphics Array, VGA. The Video Graphics Array, or VGA, is one of the most enduring and iconic standards in the history of personal computing. Introduced by IBM in 1987 alongside the PS2 line of computers, VGA was a revolutionary leap forward. At a time when most computers were limited to 16 colors at very low resolutions, VGA brought the ability to display 256 colors simultaneously and introduced the standard 640 by 480 resolution that would define computing for over a decade. For an IT technician, VGA is the ultimate legacy survivor. Despite the arrival of digital giants like HDMI and DisplayPort, you will still find VGA ports on the back of servers, industrial equipment, and older office projectors today. The science of the analog signal. The most critical technical detail a technician must understand about VGA is that it is a purely analog interface. Unlike modern digital connections that send binary ones and zeros, VGA transmits data using varying electrical voltages. This makes the signal behave more like an old radio broadcast than a modern network connection. A VGA cable carries 5 primary signals to create an image. 3 of these are the color channels: red, green, and blue. The intensity of each color is determined by the exact voltage on the wire, ranging from 0 volts for black to 0.7 volts for full brightness. The other 2 signals are the horizontal sync and the vertical sync. These act like a metronome, telling the monitor exactly when to start drawing a new line of pixels and when to return to the top of the screen to start a new frame. Because these signals are analog, they are highly susceptible to signal degradation. As the cable gets longer, the resistance of the copper wire causes the voltages to drop and the timing to drift, which is why a long VGA cable often produces a blurry or ghosted image compared to a short one. The physical interface, the DB15 connector. The physical VGA port is officially known as a high-density D-subminiature 15-pin connector, or DB15 for short. It is a D-shaped connector with 15 pins arranged in 3 rows of 5. This design was a marvel of miniaturization in the 1980s, packing 15 connections into a space that previously only held 9. Inside the connector, each pin has a dedicated purpose. Pins 1, 2, and 3 carry the red, green, and blue video signals. Pin 13 and 14 carry the horizontal and vertical sync. The remaining pins are used for various grounds and a specialized channel called DDC, or Display Data Channel. The DDC channel was a later addition that allowed the monitor to talk back to the computer to tell it what resolutions it supported. Before DDC, users had to manually set their resolution and refresh rate in the operating system. If they set it too high, they could actually physically damage an old CRT monitor. The double conversion problem. One of the biggest drawbacks of using VGA with modern flat-panel LCD monitors is the double conversion process. A modern computer is a digital machine. It thinks in ones and zeros. An LCD monitor is also a digital machine. However, because VGA is an analog cable, the computer must first take its digital image and convert it to an analog signal using a chip called a RAMDAC. This analog signal then travels down the VGA cable, where it picks up a small amount of electrical noise. When the signal reaches the LCD monitor, the monitor must then convert that noisy analog signal back into a digital image to display it. This process is never perfect. It often results in pixel crawl or jitter, where the edges of text look fuzzy or seem to vibrate slightly. This is why technicians always prefer a digital connection like DVI or HDMI if it is available. If a technician is forced to use VGA on an LCD monitor, they should always use the Auto Adjust button on the monitor. This tells the monitor to analyze the incoming analog wave and try its best to align its digital pixels with the analog peaks and valleys to sharpen the image. Interference and the ferrite bead. Because VGA is so sensitive to electrical noise, the cables themselves often feature a distinct physical characteristic: a large, plastic-encased cylinder near one or both ends of the cable. This is called a ferrite bead or a ferrite core. Inside that plastic cylinder is a piece of magnetic ceramic. Its job is to act as a low-pass filter. It allows the relatively low-frequency video signals to pass through while absorbing high-frequency, radio frequency interference that might be emitted by the computer's power supply or nearby cell phones. Without these ferrite beads, a VGA monitor might show horizontal lines or static whenever a nearby electronic device is turned on. For a technician, a VGA cable without these beads is a SIG. N of a low-quality, budget cable that should be avoided for professional installations. Troubleshooting VGA issues. When a VGA connection fails, the symptoms are usually very different from a digital failure. In a digital connection, the screen is usually either perfect or completely black. In an analog VGA connection, the screen can fail in degrees. 1. The missing color. If a VGA cable is not plugged in all the way, or if one of the pins is bent, you might lose one of the 3 color channels. If the screen suddenly looks entirely yellow, it means the blue channel is missing. If the screen looks purple or magenta, it means the green channel is missing. A technician should always start by inspecting the pins inside the connector for any that are pushed back or bent. 2. The out-of-range error. Because the monitor and computer don't always communicate perfectly over VGA, it is possible to send a signal that the monitor cannot handle. If a user sets the refresh rate to 85 Hz but the monitor can only handle 60, the screen will go black and display a floating box that says out of range. To fix this, a technician often has to boot the computer into safe mode or low-resolution mode to reset the display settings to a safe baseline. 3. Ghosting and shadows. Ghosting appears as a faint, blurry duplicate of an image shifted slightly to the right. This is almost always caused by a poor quality cable or a cable that is too long. In an analog system, the signal can echo or bounce back if the cable's electrical resistance doesn't match perfectly. Replacing the cable with a higher quality double-shielded version usually solves the problem. The survival of VGA in the modern world. You might wonder why we still care about a 40-year-old analog standard. For a server technician, VGA is essential because it is incredibly reliable and dumb. A VGA port doesn't need complex handshaking or digital security keys like HDMI. This makes it perfect for the basic text-based console output of a server. Many high-end data center switches, known as KVM switches, still use VGA because it allows a single technician to manage hundreds of servers with one simple, reliable interface. In conclusion, while VGA has been surpassed in every performance metric by digital technology, its simplicity and near-universal compatibility ensure it will remain in the technician's toolkit for years to come. Understanding the nuances of its analog signals and its physical vulnerabilities is a foundational skill for any hardware professional.